All right, so AM was amplitude, that's an A. Amplitude modulated. And FM means they tweak the frequency over a narrow little range, because you see in the picture that the amplitude stays the same, but the wavelength changes just a little bit, and so it's kind of has a slightly different speed. Like when you're picking up speed, you change speed, and you change speed, and you slow down when you're talking. And so we change the speed, not the speed, we change the frequency with which the wave moves a little bit. And if you listen to whatever radio station you listen to, like someone yesterday had 96.3 hertz, or they said they listened to 96.3, that is the frequency of the radio station. Now, it may not necessarily be hertz. Some of the newer cars will show what the frequency is, and sometimes it's really this. They have a capital M in front of it, and that means megahertz. So if you see an M in front of it, you need to multiply this number by 1,000,000 before you put it into the problem. Otherwise, you'll be off on your answer. Okay? Now, by a show of fingers, how many of these types of waves are non-ionizing, meaning that they don't cause cancer? Alright, the answer is 2. Of the ones that are shown, these are the non-ionizing, meaning they don't damage DNA in your cells. The thing that's kind of interesting about this, come on. Every one of these is a form of telescope. You can go to NASA and say radio wave telescopes, and you can go NASA and what are microwave telescopes, and you can go UV and X-ray and gamma. All of these are different types of telescopes because they're all ways of seeing and detecting the universe. It's just in different spectrum. Okay? For instance, you can do it, computer. Come on. There we go. This was taken in 2010, 2011. These are the moons from Saturn, like it says in the icon or in the blurb here. What they didn't have on the website was what the temperature scale actually was. So I have no idea if the color gradient here is 5 degrees. It could be 1500 degrees. I don't know. But all the NASA people, because they're my generation probably or a little younger, they look like Pac-Man. They thought this was hilarious how the infrared showed up this way. So this is just a heat signature of these moons, and it shows them as being hot and cold in kind of a weird pattern, not what you would expect. Okay, the way to think about this and answer this question, remember the giant chart that I showed you. The danger was over here, radio was over here, and then we had Roy G. Biv. Okay, infra means below, so infrared is right here. So can you remember what the waves look like? Would that have a long wavelength over here, or would it have a short wavelength on this side? And the answer is long. Okay, the way to remember that, if you can imagine that diagram, left side has long wavelengths. So for those of you that need an alliteration or a verbal way to remember it, L and L, left or long. Okay, now flip to page 535. And someone from table 2, read us that practice problem on page 535. So that's what I've picked up from the reading, but I don't know what V is. Well, some of you may know this, or you may have seen it in the practice problem there. This is one of the constants that you need to know. Just like you had to know 9.8 was the acceleration due to gravity, every wave on the electromagnetic spectrum has the same speed. Doesn't matter if it's a radio wave, visible light, gamma ray, X-ray, microwave, whatever. If it's on the electromagnetic spectrum, it has the same speed. This is a number you need to know. 3 times 10 to the 8th meters per second. That is the speed of light. Okay? Just like on the energy problems, they didn't have to tell you what gravity was. They are likely not going to tell you what the speed is. So when you raise your hand on the test because you've panicked and you forgot that you're supposed to know this, and you're like, well, we can't do this problem because we don't have V, I'm just going to walk away. All right? This was one of the constants that you have to know. If you still remember how, or you can always go watch the video on how to do this, you can always save that to your calculator. So 3 times 10 to the 8th is equal to frequency I don't know times this does not match this. And even the hint in the problem told us this. So make sure we change that to meters. So I have a giant number and I'm dividing it by a decimal. This means it should get bigger. Okay. Remember how we were working on using exponents so we could predict what an answer would be? 0.19 is the same thing as 1.9 times 10 to the minus 1. Okay? So this means at the very least, my answer should be 10 to the 9th when I'm finished. And if you did it right, you should get something like 1.58 times 10 to the 9th. If your calculator is one of the newer ones, you can actually fit all 9 digits on your screen. And if you want to write out all 9 digits, knock yourself out, but make sure that you have all 9 digits, otherwise you're off by a power of 10. We need to figure out what our unit is. This was meters per second, and we divided it by meters. So that means, I'm going to erase this and work up here. We'll see how good you guys are at your units and fractions. So if I have meters per second, I'm dividing it by m over 1, because any number, any unit, I can put over 1. Okay? So that means if you're dividing fractions, you multiply by the reciprocal. Well, that means I would get 1 over second. And we saw something similar to that earlier. What was the unit for frequency? It was hertz, which was number per second. Okay, if you want to be a fancy pants person, you can write second to the negative 1 or just s to the negative 1. All of these are the same unit. Okay? All of these are the same unit. So I'll give you a few moments. Let's see if you can come up with an answer on number 2. You should have had something about 441 meters. And if I were to ask you how many times around the track that is, you should be able to tell me. Which means that wavelength from here to here is more than a quarter mile. Because 400 meters is one lap on the track. Alright, that ends us for today. There'll be part of a video, and then you'll have a worksheet. There is a front and a back to the worksheet. Do both sides.